All right, so our objective is to find experimental probability and its complement. So that means we're going to be doing some experiments today. So we're going to be rolling some dice, or we're going to be flipping a coin. We're going to be doing something to figure out what the probability is. All right, so it says, toss a paper cup a number of times and record the different ways the cup lands on a table. Describe each way that the cup lands as likely or unlikely. Organize your results in a table. All right, so let me grab my cup. All right, so here's my cup, and we are going to toss it. How many times does it say? Okay, it doesn't. So we're going to do it 10 times. So 10 times. So my outcomes should be 10, my total outcomes. All right, so I'm going to flip it, and it lands on its side. So on its side. Okay, I'm going to flip it again. Okay, on the side. Keeps hitting my thing. So on the side. On the side. I know I probably should flip it on the ground, huh? Yeah. Might be better. All right, I'm going to do it on the ground and see what we get. Nope, still on the side. Yep, on the side. Nope, on the side again. I think we're going to end up with all on the side.
Imagine the last one is like on the side.
Nope. All right, and we got one more. Oh, almost. All right, so 10 on the side. All right, so. Thank you. So now we're going to write it as likely or unlikely. So it is likely that the cup will land on its side. And then it's unlikely that the cup will end up or down. Okay? All right, so the turn and talk says, how do you think increasing the number of times you toss the cup would change your results? Well, the only thing that's going to change is the number of times it lands on the side will increase. So up or down will increase, but not as fast. Okay? All right, are we good to move on? All right. Sorry, trying to get kids who log in tardy. All right, so to our build understanding, we're going to conduct an experiment by flipping a coin, and we're going to record the results in the table. Repeat until we have conducted the experiment 20 times. All right, so I'm going to use a website. Sorry, I got to figure out where I put them. Oh, wrong one. We're going to need that one too. I'll go ahead and keep that one open. Alright, so let me reshare so you can actually see the screen. Alright, so you should be able to see a coin, right? And so instead of tossing it one at a time, I'm just going to type in how many tosses I want, which is 20, and then we're going to record it from there. All right, so I'm going to hit toss it. All right, so there's my results. So you can see I got 1, 2, 3, 4, 5, 6 tails. All right, so we're going to go back here. I'm going to write 6 tails and 14 heads. All right, so the question says, how many trials did we conduct? So we had 20 trials, right? Because I flipped it 20 times. Does the outcome appear to be equally likely based on the results? Well, if you look, heads was 14 times, tails was 6. So based on the results, was it equally likely? So I would say, based on the results, they were not equally likely. Now, if we're talking theoretical probability, we should have had half and half, right? 50-50. Because you have a 50-50 chance of flipping a head or a tail. So theoretical probability should have been 50% or half. But based on the results, tails was not equally likely. All right, so now we're going to fill this out. So it says use the number of times each event occurs compared to the number of trials to approximate the probability of the event. So the probability of heads was 14 out of 20. The probability of tails was 6 out of 20. Okay, so the question says, if you flip the coin only 4 times, do you think it is possible that you might record only tails and no heads? What if you flip the coin 100 times? Compare the chances of the two probabilities. All right, so 4 times, it's probably unlikely, but possible for both all tails or no heads. So it probably won't happen, but it could be a possibility. Okay, then the second part of the question says, what if you flip the coin 100 times? Well, if it's definitely unlikely for 4, it's definitely going to be unlikely for 100. Because as you continue to flip that coin, there's no way you're going to get 100 times that it's all heads, right? Or all tails. So as we flip, the coin more, it becomes unlikely that all tails will happen. Yeah. Upload in a focus. That'll be easier. All right. So it says, what happens to the number of times each outcome occurs as you perform more trials? Okay. So as we start doing more, we should get closer to the theoretical probability. So the number of outcomes for heads and tails come closer to being the same. So then it says, what is the sum of the probabilities in part B? Well, if I add 14 over 20 and 6 over 20, I should get 20 over 20, which is 1. So then the turn and talk says, are there any outcomes that did not occur in your set of trials? So that would be no. And why is it so? Well, we can only, O-N-L-Y, only get heads or tails. I can't get anything else. It's a clip. It's a coin, right? So that's all I can get is heads or tail. All right, so I'm going to pause just for a second to give you guys some time to copy that. All right, let me know if anybody needs more time. Type it in the chat, please, if you need more time. All right, I don't see anything, so I'm going to move on. All right, so now we have a spinner. And it should, if you don't have a book, guys, it actually looks like this. So red, blue, green. Okay? So the experimental probability of an event is found by comparing the number of times the event occurs to the number of trials. So experimental probability, number of times the event occurs over the total number of trials. Muriel has a spinner with red, blue, and green sections. She spins the spinner 50 times. So that is your trial. And records the results in the table. So it says, Find the experimental probability of each outcome. So what is the probability of spinning a red number? How would we write that? So number of outcome over the total trials. So how would we write that? Yes, thank you. 14 over 50. Okay, so if we want to find the percent, I can increase it to 100. So that gives me 28 over 100, or a 28% probability that we will get red. Okay, what about the probability of blue? How would I write that? Yep, 12 over 50. Okay, but I can scale it up to 100, right? So then what would my percent be? Nope, I got to multiply 50 times 2, right? So I got to do the same thing with 12. So what would my percent be? 24, yep. So that would be 24%. All right, what is the probability of getting a green? Yeah.
So somebody put up 24 over 50.
Yep, I got it. All right, and then as a, can you try to log in through single sign-on?
What's that?
Where it comes up and it says DCPS login, and you click that.
Mm-hmm.
Were you ever able to get in it?
Mm-mm.
Okay, I'll have to send a message to Miss Smith. Sorry, guys, I have a couple kids in here doing makeup work. All right, so this would become what? 48%. Yep, 48%. Awesome. All right, so it says, what conclusions can you make about the spinner using the experimental probability? So what do we know about the green section?
It takes half most of the circle.
Yeah. So green is the same size as red and blue together. Can you log into Math, Alexis?
It doesn't log into anything. I tried and it didn't work. It says,
Were you ever able to get into Math?
Mm-hmm.
That's weird. Okay, I'll have to look at it.
Last time, like I did my work on there. And
Okay, I'll have to look at it when I'm done with this. Okay, so then, what do we know about blue and red? Yeah. Do I have what? Yes.
Does she have red hair?
Oh, it says blonde hair. All right, so red and blue appear to be the same size. So we can't really kind of make the assumption because it doesn't really tell me they're the same size, but we can assume that we think they're the same size, right? So that's why I put they appear to be the same size, but unless it tells me that they're the same size, we don't 100% know. All right, so C says, how would you find the experimental probability of the spinner landing on a color that is not red? And what is the experimental probability in this example? Okay, so if the probability of red, so this is kind of like the complement, the opposite. So if the probability of red is 14 over 50, the probability of not red would be blue and green added together. So we would add 12 and 24. So what does that give me? So 36 out of 50. Okay, so if this one is a 28%, this one would have to be the remainder, right? So 100 minus 28. So it gives me 10 minus 8 is 2. 9 minus 2 is 7. So that is a 72%. Okay? So this is the probability. This is what we consider the complement. So it's the opposite of what we wanted. And that is the vocabulary word right here. The complement of an event is the set of all outcomes in the sample space that are not included in the event. The sum of the probability of an event and the probability of its complement should equal 1. So if I was to add 36 and 14, I would get 50, and we know that 50 over 50 is 1. So that's what they're talking about. So how is the experimental probability of the spinner landing on a color that is not red related to the experimental probability of the spinner landing on red? Well, we just said it is the opposite, or it is the complement. All right, so E says Mural spins the spinner another 50 times and records the outcomes. Do you think the experimental probability based on the results will be the same as the ones in part A? So if we did it another 50 times, do you think we're going to get exactly 14, exactly 12, and exactly 24? Do you think that would happen again? It's just like flipping a coin. So if I go back and flip this coin, and I say toss it again. Oh, I need a clear result, sorry. Let's see what we get. So look at this one. This time, last time we only had 6 tails. Now we have 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 tails. Okay? So just like Hillary said, no. It's possible, because, you know, anything's possible, but not. So no. It's possible, but not likely. Each time you conduct an experiment, the results change. Okay? So if I asked every single one of you in here to flip a coin or spin a spinner, every single one of us would probably get a different outcome. All right, so do I need to pause? Oh, sorry. Let me know if we need more time. Okay, Hillary said no. Brandon said yes, so I'll give Brandon a few more minutes. All right, so I'm assuming, Brian, that means you're good to go. I don't know what that means. All right, so I'm assuming that means we're good. And if not, I can go back. Okay. All right, so the last one says a simulation is a model of an experiment that would be difficult to actually perform. A simulation can be used to find an experimental probability and make a prediction. All right, so for example, this one talks about softball. So we all can't just go outside right now and go hit a softball to find our probability. So we're going to use a simulation. So a softball player hits the ball and reaches base safely 30% of the time. A player hits the ball but is called out 50% of the time. And a player strikes out 20% of the time. How can you use a random number generator to simulate the next 25 times the player comes up to hit the ball? All right, so since we know this adds to 100%, we really don't want to use from 1 to 100 because that would be too large, right? But we know that if we had something like 3/10, we know we could scale that up to get 30%. So what I would do is I would use random numbers from 0 to 9. Okay? And if you want to use 1 to 10, it doesn't matter. Okay? But I'm just giving you an example. So I would use from 0 to 9. Okay? 20%, so that would be 2 numbers. So I'm going to say 0 and 1 would be strike out. So I'm going to put down here strike out is going to be 0 and 1. Okay, 30, so I need 3 numbers. So I can use 2, 3, and 4. Well, that should go here. 2, 3, and 4. So that would be safe. So 2, 3, and 4 would be safe. And then called out would be 5, 6, 7, 8, and 9. Okay? So it says make a prediction about your simulation. So what do you think is going to happen? Before we even predict it, what do you think is going to happen? %50 is called out, right? So I would say that we're going to have a lot of numbers, right? So I would say we're going to have a lot of numbers around 5 to 9 because that's what that is telling me. I'm 50% that I'm going to be called out. All right, so I'm going to use the random number generator site, which is this one. I'm going to change my minimum and median. And guys, I will post this in the Teams so that if you guys want to play around with it, you have it. I'll post it in the chat. Okay, so there's the website. All right. So then what we're going to do is we're going to copy it down. So every time I say a number, make sure you write it down on your table, and then I'll show you the table at the end of the one I did. All right, so I'm going to generate the first number. So that's an 8, so that's a strikeout. Okay, and we have to do this 25 times. Okay, number 1. No, I'm sorry. So 8 was an out, 1 is a strikeout. Okay, do it again. Number 9, so I'm out. Number 3, I'm safe. 0, I struck out. 2, I'm safe. 8, I'm out. 4, I'm safe. 7, strikeout. 6, strikeout. 4, safe. 5, strikeout. 3, safe. 4, safe. Oh, we're close. We're even. 7, out. 6, out. 4, safe. We're at 17. 3, safe. 4, safe. Wow. 8, out. 5, out. So we're at 15, 16, 17, 18, 19, 20, 21. So 4 more. 2, safe. 9, out. 6, out. 5, out. So this is what you should have. So we have 10, that was safe, and 13, and 2. So that's what we got. All right, so D says combine the results of your simulation with the results of all the simulations. So if we would have all done this individually, we would have taken all the simulations and added them together. Okay? But we didn't do them all separately. So I could do another one. Did anybody happen to do one? Did anybody happen to do their own experiment? No? All right, let's do it one more time and let's see what we get. All right, so one more time. All right, so I got a 9, a 7, a 1, a 0, a 3, a 2, a 3, a 0, a 5. I'm going to do it kind of fast so I can get it over with, okay, guys? A 3, a 9, a 0, a 2, a 3, a 9, a 1, a 0. Wow, this is close. A 7, a 6, a 7, a 2, a 3, 15, 16, 17, 18, 19, 20, 22, 23, so 2 more. A 4 and a 2. Wow. Okay, so if we do look at that one, we have 10, 14, and 6. Is that 25, or do I need to do a couple more? Or did I do too many?
Did you do 30?
I did 30. Yep. My bad. I don't remember the last ones we did. So we'll take one off. We'll take 2 off of here, 1 here, 1 here. Yeah, I did 30. All right, so that worked better. So that would be what? 12, no, 5, 6, 7, 7, and 5. Now I did too many, didn't I?
Actually, I thought it'd be interesting to see the 30 because then you could see if it tracks with the other stuff. But
Yeah.
it's a little late for that.
Well, I can see what I've done.
Okay.
I can see where I erased them. All right, so this was 10, 14, and 6. So that was 30. All right, so we still can do the percent though, right? All right, so the first one would have been 10 out of 25. And then the second one, so that would be out of 100, that would be 40, right? So this would be safe. And then the probability of out would be 13 out of 25, which would be 13 times 4, which is 52. And then the probability of a strikeout would be 2 out of 25, which would be 8 out of 100. Yeah. All right, and then this one would be 10 out of 30. So 10 divided by 30 is going to give me a little bit different. So that's going to be a 33%. So this one is 40, this one is 52, and this one is 8. And then this would be 14 out of 30. So that is 46%. Actually, it's more 47%, but. And then this one would be 6 divided by 30. And that would be 20%. So we can go back and look, right? So 40, so getting out, which we thought should be about 50%, is somewhere around 42 and 47. Okay? So those are pretty close. And then this one didn't even make it to the 20%. But this one did. And then as you can see, 33 and 40. So the second time we did it, we got a little bit closer. Okay? So as you can see, guys, when we do experimental probabilities, we're never going to get the same percentage. Okay? All right, so We will work on the check understanding tomorrow as well as the on your own. Okay, are there any questions? All right, so guys, next week we will not have class but on Wednesday. Okay, because everybody should be coming in to take the FSA. Okay, so next week the only class we will have is on Wednesday. Those of you that today is your first day of logging in for a very long time, the groups are listed on the daily agenda. All right? All right, you guys have a great afternoon. I'll see you tomorrow.